For example, this is a server. I can do it. Can't ping this server. But you can remotely telnet to this server. We'll have a comprehensive exercise in a moment. I'm going to show you this part. That is, although PC1 cannot ping PC2, but it can log in remotely. So now the equivalent of, just hope it doesn't ping. We call such a function ping ban. But PC1 accesses other services, or provide it. So we cannot directly deny all traffic from PC1. Otherwise, PC1 can do nothing. We should use advanced ACL here. Its overall number is between 100 and 199. We will enter 100. Here is a deny and permit. Don't worry about the remaining two. We know these two at this stage. We must deny its traffic. Deny. Then you can see the message here. Various protocols. Then there is one of them called ICMP. We just want to deny its ICMP message. That is, deny one of its ping packets. After we enter ICMP, enter another question mark. Here is a source address. As source address, it can be a network segment. But you see there's a more precise one under it. A single source host. It's called the target host. I give a simple example. For this picture. Now PC1 is 10.1. If a switch is connected under this device now, the switch is connected to a 10.2 address here. Same network segment as PC1. If you are now on this interface of the router, deny such data from the entire network segment of 10.0. Then in the future when 10.2 goes to ping 20.1, it also can't ping. So often, our requirement is that PC1 cannot ping PC2. We will not target the entire network segment where PC1 is located. Use the entire network segment of the address. We don't do that. We often choose this host. That is, use a single exact host address. Since we want to limit PC1, just let it match the overall flow of PC1 precisely. Only affects it. In the future, if there is a device on the same network segment as PC1, they have nothing to do with ping PC2. So here we do intercept. Only for such a precise IP address. So we use host here. We need to configure the address of host A. 192.168.10.1. Then I will put a question mark. Here is a destination address. There is also a single destination host below. So we still hope that it can go to 192.168.20.1 alone. Mean the same. I just hope it can't ping PC2. In the future, if PC2 has a 20.2 on the same network segment, then PC1 is also allowed to ping through. So we minimize the range of lethality. Remember my words. When we are doing ACL in the future, what do you need? What kind of corresponding configuration do you make? Do not go beyond what is required. Okay. This is an exact address. Enter a question mark at the end. This is when we limit ICMP messages in the future. The following parameters you can configure. Let's find out which one is the parameter we want to use. It is this. Called echo. I hit enter. Then exit. We can look at the configuration of the ACL. Access list. I configured a 100 here. This is the high-level ACL of 100. It has a number of 10. Deny the echo message in the ICMP service. From host PC1 to host PC2. We specifically enter such an ACL. But you will find, we seem to have not entered the previous 10. It is a serial number inside the ACL. You can also understand it as a number of ACL rules. Multiple rules can be defined in an ACL list. There is such a containment relationship between them. So what does this tend mean? For example, I will now enter another access list 100. I add a deny ICMP to it here. This is optional. We do not currently have such an address. 192.168.10.2. Then the destination address is 192.168.20.2. Then we type an echo. I just typed 10.1 and 20.1. 10.2 and 20.2. Let's enter another one and see the phenomenon. This does not affect the configuration we will wait for. Deny ICMP host 192.168.10.3. Then enter a destination host. 192.168.20.3. After we have entered, check out the command just now. You will find. Now there are 2 more in the list. You will find that their overall order is. Starts with 10. Then 20. Then 30. This is called the step size of the entire rule. You can define your own rules. That is, you can define this serial number yourself. If we don't define this ordinal, it starts with 10 by default. And then accumulatively 20, 30 and so on. So now you can see that there are so many matches in it. The first clause means it denies the ICMP message from 10.1 to 20.1. Its second article denied this again. The third deny this. What do you mean by this? I give an example. If we go to match, for example, there is an ICMP echo message from 10.1 to 20.1. It will be matched by the first. If there is a 10.2 going to 20.1 now, then it will compare. It will compare with the first one to see if it can match. Can't match. Because the source IP is different. Then it goes to match the second. Can't match. Because the destination IP is different. Then it goes to match the third. Can't match. Because the destination IP and source IP are different. If a data comes in Cisco, it does not match any of these 3 rules in all lists. Then we will discard this data packet. We will deny this data by default. That is to say, for Cisco, if we are doing ACL configuration, there is no corresponding matching item for some data in the ACL. Then after you call under the interface, Cisco will have a default command called deny any. That is, if for a data you did not deny or permit it, then it is deny by default. For example, now comes a 1.1 to 2.2. When you come here, you will deny by default. Because although it is not clearly stated that this is a default configuration, sometimes everyone go to other places to configure commands. You have to pay attention to this. That is to say, when we are configuring Cisco, there is a very critical order. You must know. What we just entered is access list 100. Then let's permit here. When I now permit, I enter a question mark to see. What I am doing now is the configuration of advanced ACL. Then inside I should go for the next parameter is IP. In the ACL, if you don't know what protocol you're matching, that is, no clear rules. Unlike the demand we are talking about today. Can't ping. Ping is an ICMP packet. You only know now. I don't want PC1 and PC2 to access. But there is no explicit access restriction. Then we use the IP. You can see that it is written after any Internet protocol. Now all these agreements you can see. In fact, they are all Internet protocols. Both belong to the protocol of the IP layer. Of course, some are higher. But I'm going to tell you. If you don't know what to type, You just enter the IP. It will match the service on all of these now. We enter the IP here. Later it writes source address. You need to let go. Or, how much traffic do you need to specify? How much to enter here? We want to allow traffic from any to any, which is equivalent to, in Cisco equipment. You finally finished configuring the ACL. To enter a command like this. Otherwise, as long as you don't make explicit data, all are deny. Then in the future, there will be a lot of internal hosts that will not be able to access the internet. You must enter a command like this. Permit any. That is, all future traffic from anywhere to anywhere is allowed. I just deny the rules I just made in it. This last command must be remembered. It shows in the list. Is such a concept. That is to say, source is any. The purpose is also any. We allow all traffic. The whole list is now complete. I have sent ICMP request packets from PC1 to PC2. It's all denied. Now PC1 seems to be able to ping PC2. Because we are now only matching the parameters. And defines the matching action. The matching parameter is PC1 to PC2. The matching action is deny. But now there is no hooking under the interface.